Now we are continuing with the topic of finding the area bounded by two curves or between the graphs of two equations. Those statements mean the same thing. So for our example today, it says find the area of the region between the graphs of, and the first one was y is equal to 3x to the third minus x squared minus 10x. Second one is y is equal to negative x squared plus 2x. So I made the first equation f of x. I made the second equation g of x. I found a window here that I can nicely see what needs to be seen. Now, one of the key differences between this problem and the type that we did prior to this problem is we end up getting two bounded regions here. We got this region here that's on the left, and we got a second region that's on the right. Okay, a second key difference that separates this problem from most of the ones we've done so far. In this region here, the top curve is the blue one, which is the cubic, the bottom curve being the quadratic. And in this region, that flips. The top curve is the quadratic, the bottom curve is the cubic. So when we set up our formula, subtracting top minus bottom, it's going to flip for the two regions. All right, now on to how do we accomplish this using Desmos. We need to know this point of intersection down here. So I'm going to click on one of my two curves, click on that, and we know it's at -2, -8. As we discussed in a previous video, when we go to do other things, those coordinates tend to disappear. So I want to put them in such a way where they stay there for when I need them. So -2, comma, -8, and I'll label that. So that's there now for the remainder of the problem. All right, this point right here, it appears as though they're crossing in 0, 0. And if you check it, it does, or they do. And right here, it looks like they're crossing at 2, 0. And if you check it, they do. And that's kind of common sense visual. I'm not going to label those as points like I did down here. All right, the next place I'm going to go to is to set up my integrals. So I'm going to go to Function. In the Miscellaneous menu, I get the integral, and I'm going to need two of them, one for the left region and one for the right region. So for this region right here, we're integrating from an x value of -2 to an x value of 0. And top curve minus bottom curve. The top curve for this one is the cubic, which is my f of x. And then the bottom one is the quadratic, which is my g of x. Close those parentheses, integrating with respect to x, and that is the first part of our integral. First part of the final answer, the integral for the left region. Now we need to set up the second one. So I'm going back to Functions, Miscellaneous, Integral. Here my x values are from 0 to 2. And for the subtraction, it's the quadratic on top and the cubic that's on the bottom. So it's g of x minus f of x. And as always, for what we're doing with respect to x, and that gives us that total bounded region of 24 square units. So in summary, the difference between this problem, or one of the differences between this problem and the ones we've done previous to this, we have two regions that get bounded instead of a single region. And then the second key difference is what is the top curve and what is the bottom curve changes going between those two intervals.